For centuries, humans searched the sky for proof that life exists beyond Earth. Now, scientists detected strange chemical signals on a distant planet that refuses explanation. These signals mirror processes tied to life itself. The question feels unavoidable now. Are humans finally witnessing the first real evidence of alien life? What scientists mean by alien life? Clearing the confusion. When people hear alien life, they often imagine intelligent civilizations, spaceships, or advanced technology. Scientists think differently. Their first goal is much simpler. They search for basic life forms, tiny microbes and bacteria that thrive in oceans, soils, and extreme environments. These organisms matter more than intelligent beings because they prove life itself can exist beyond Earth. To scientists, life is not about intelligence or gadgets. It is about survival against all odds. Imagine microscopic organisms clinging to existence in boiling springs or deep ocean vents where nothing else can live. They take energy from their surroundings, hold themselves together, and persist long enough to change. Life on Earth began in places like this, when the planet was wild, unstable, and unrecognizable to us today. Survival came first. Everything else came later. Long before animals or minds existed, microbes were already adapting in hostile environments, quietly proving that life does not wait for comfort. This idea shifted from theory to possibility with the study of a planet called K2-18b, a distant world whose atmosphere immediately caught scientists' attention. Early observations revealed carbon dioxide and methane together. Both gases are ordinary on their own, but together they resist explanation. On Earth, they tend to cancel each other out unless something constantly replenishes them, and often that something is life. Even more intriguing, early data hinted at dimethyl sulfide, a molecule almost entirely produced by living organisms on Earth, particularly microscopic ocean life. Detecting even a trace of it on a distant planet was unexpected. Suddenly, the question was no longer whether alien life could exist, but whether its chemical traces were already whispering across the cosmos. The James Webb Telescope and chemical fingerprints of life. The James Webb Telescope did not capture oceans or organisms. Instead, it measured light as K2-18b passed in front of its star, tracking subtle shifts as starlight filtered through the atmosphere. That light carried the planet's chemical story, shaped by gases and particles along the way. For scientists, it was like reading fingerprints left at a scene, incomplete but revealing. K2-18b was no longer just distant. It had become a planet that demanded attention. The signals were faint, barely more than a whisper, yet they were impossible to ignore. One misstep could turn a tantalizing clue into a false alarm. Unfamiliar chemistry, extreme temperatures, or exotic geological processes might mimic life. The universe has ways of imitating biology that scientists are still trying to understand. This is where the story gets really interesting. The data does not prove life, but it does not rule it out either. If life is behind it, it could be hiding under a global ocean, trapped beneath thick clouds and extreme pressure, surviving without sunlight in ways Earth life barely shows us. If not, then nature might be creating chemical signals that look like life in ways we do not yet understand. Either way, it changes what we thought we knew. Then comes the clue that grabs attention: dimethyl sulfide. Now on Earth, this molecule comes almost entirely from tiny ocean life. Seeing even a hint of it on K2-18b is surprising. Could it be a sign of life, or just a strange chemical reaction? No one knows yet. Every time Webb collects new data, scientists watch carefully. Does the dimethyl sulfide signal grow stronger or fade away? Does the chemistry stay the same or change in ways that surprise us? Each new measurement could bring us closer to an answer, or make the mystery even bigger. A new type of alien habitat, the Hycean world theory. K2-18b is not just another distant planet. Its discovery sparked the idea of an entirely new kind of alien habitat, Hycean worlds. Imagine planets covered almost entirely by deep, dark oceans, cloaked beneath thick, hydrogen-rich atmospheres. These worlds could be vast water worlds, where sunlight barely penetrates and weathered clouds swirl endlessly above. Their internal heat and immense atmospheric pressure might keep oceans liquid for billions of years, even if the planet drifts far from its star. In other words, life could exist there in ways that are completely alien to us. Scientists think K2-18b fits many of the predicted traits for a Hycean planet. Its size, orbit, and atmospheric hints make it a prime candidate. But it's important to note that no Hycean planet has been confirmed yet. Everything we know is based on models, chemical fingerprints, and careful observation from light years away. Even so, the possibility alone reshapes how we imagine where life might survive. Now comes the most surprising part. Life in these oceans could be completely unlike anything on Earth. Imagine organisms surviving under crushing pressure, hidden beneath thick clouds, never seeing sunlight. On our planet, sunlight powers almost all life, so the idea that life could thrive without it is astonishing. In Hycean oceans, organisms might get energy from chemistry instead, using hydrogen, methane, and other chemicals as fuel in ways we can barely imagine. Many microbes could create entire ecosystems in total darkness, while giant ocean creatures might exist too, shaped by pressure, cold, and chemical energy rather than sunlight or familiar food chains. The real wonder is what such life would teach us about biology itself. It would show that life can adapt to conditions we once thought impossible, and that the universe may be far more inventive than we realize. Even the discovery of the simplest organisms in a Hycean world would rewrite our understanding of where life can exist. It would mean that habitable worlds are not limited to planets like Earth, and that the universe could be full of surprising, hidden forms of life waiting to be found. Each new observation deepens the mystery. Scientists study the atmosphere, looking for gases like methane, carbon dioxide, or even dimethyl sulfide that might hint at life below. They analyze temperature variations, cloud patterns, and planetary heat to see if conditions could truly support living oceans. The questions are endless. Could life in a Hycean ocean evolve complexity without sunlight? Could it even communicate or move in ways we cannot predict? If Hycean worlds exist, they'd completely change the search for life beyond our solar system. They suggest that habitable zones are not just about distance from a star, but about chemistry, pressure, and oceans hidden under clouds. Somewhere out there, in the deep dark of a Hycean ocean, the simplest forms of life might already be waiting, silently leaving traces for those patient enough to uncover them. Why scientists are careful and why that caution matters. Now, one of the most misunderstood parts of searching for alien life is the patience it demands. To the public, signals from K2-18b seem dramatic, almost certain. But to scientists, they are fragile, buried under noise, uncertainty, and assumptions that must be tested over and over. This caution is not hesitation. It is survival for science itself. Astronomers cannot visit K2-18b. They cannot plunge into its oceans or breathe its air. All they have is light that has traveled over 100 years, carrying hints of the planet's story. That light is fragile, twisted by distance, filtered through instruments, and shaped by chemical processes we are still learning to read. One misread signal can turn a hint of life into a false alarm. The universe has a way of imitating life, as history has shown. Methane on Mars and strange signals from Venus once suggested living worlds, only to be explained by nature alone. K218b, scientists are looking at a puzzle the universe has left for them to solve. That is why scientists speak in cautious terms. Words like possible, consistent with, and suggestive dominate the conversation. Declaring alien life too early could shatter trust in science itself. Instead, each observation shapes the next. Future missions inspired by James Webb will probe atmospheric chemistry with sharper tools, track cloud layers, measure temperature shifts, and watch for repeating patterns that hint at activity below the clouds. No single clue will ever suffice. The careful, patient pace is what makes any discovery certain. When scientists finally declare that life has been found, it will not be a guess or a flashy headline. It will be the result of years of testing, ruling out other explanations, and confirming results again and again. The quiet moments between observations are where understanding deepens, where the universe keeps its secrets just beyond our reach, waiting for the next clue. So the question remains haunting in its simplicity. What will it take for humanity to finally know we are not alone? What proving alien life would change forever? Confirming alien life would reshape science in a way nothing else ever has. It would prove that life forms naturally wherever the right conditions exist, rather than being a rare accident tied only to Earth. Biology would no longer feel local, it would feel universal. This discovery would also change how humans see themselves. For all of history, humanity has lived with the idea of isolation, alone on a small world in a vast and silent universe. One confirmed microbe beyond Earth would shatter that belief. It would mean life belongs to the universe itself, not to one planet. Philosophy and identity would shift overnight. Questions about meaning, purpose, and place would feel different, heavier, and more connected. Even the simplest organism drifting in a distant ocean could change everything humans believe about existence.